Let's now move slowly into adaptation and mitigation. So we looked at a range of observed impacts. We did that under modern climate change, and we revisited many of them in future climate change to put it in the context of what is being projected beyond just temperature and precipitation. Now we will go more into how to begin to plan for adaptation and mitigation. So what does that mean? So we said essentially when we developed the RCPs, especially RCP 2.6, we said is meant to keep the global warming by 2100 to below 2 degrees centigrade. This requires that we seriously do some adaptation to reduce emissions and risks and vulnerabilities and increase resilience, and also do mitigation to draw down emissions or just reduce emitting in the first place. So here is a good list of examples. Change in land use and relocation. So right now almost 50% of the population lives within 50 miles of the coast. This is supposed to increase continuously into the future decades because there is usually a lot of economic activities and other attractions to be close to the coast. That relocation basically means as sea levels rise and storm surge etc. are expected to increase, you do not allow people to build in the first place, but also ask some of the people who are already there to begin to move. Same if you are living at the bottom of a mountain which has a landslide every now and then, and the landslides are increasing in number and so on. So change in land use is basically recover abandoned lands or afforestation, so recover deforested lands and so on and so forth. Emergency and business continuity and planning, so always plan for increased extreme events, especially like what happened in 2018 across the globe. Upgrades and hardening of buildings and infrastructure, so buildings should be made more resilient to storms, extreme rain and heat. How to soak up the water when there are extreme rains, so permeable pavers, rain gardens, rainwater harvesting. Some of this is already happening in many cities in India. You cannot get permission to build new homes unless you have rainwater harvesting planned into the construction. Residential programs and promoting adaptation, so region specific solutions, like if you are in Pune and you are in Panchavati, planting trees there, planting trees over the cities, what to do with the tillage practices in agriculture, how to get rid of the crop residues, not burning them, and so on and so forth, and many health programs so that the impact of warming or pathogen increase in cholera, malaria, etc. have to be taken care of. Under mitigation, you have energy conservation and efficiency. Keep on improving the efficiency of the vehicles, but also washers, dryers, cell phone batteries, anything you can think of. Renewable energy, obviously wind, wave, solar, geothermal and so on, nuclear. Sustainable transportation and improved fuel efficiency. India at least announced a plan that they will go completely electric by 2030, I think. I have an article on that you can look up. So sustainable transportation, you see lots of gas-based buses and so on already. Capture and use of landfill and digester gas. So garbage, use it for landfill. Generally it is thrown into a landfill and it doesn't rot as easily because many have been treated, they are plastics and so on and so forth. Also create ways to convert them into gas, convert them into more biodegradable materials, and carbon sinks, natural and artificial. Exciting research like artificial trees is going on. Right now they are too big, but it basically takes air that is flowing through, converts it into calcium carbonate and precipitates out and takes carbon dioxide out of the air. Okay, you can look up many examples. I will show a couple at the end just for saying how exciting some of the new things are. So between adaptation and mitigation, there are many co-benefits and there are many overlaps. like ceiling buildings, that is going to reduce the heat loss or the use of air conditioning and emissions. Air conditioning, heating, some of the largest emitters, and they are going to increase in countries like India because the warming is going to demand more air conditioning. Green infrastructure, you know that getting certified as green building is a big deal now. So recycling water, saving energy, minimizing energy use, and so on and so forth. So water and energy conservation is a big thing for all industries, apartment buildings, even at cities if they are smart cities and so on. So smart growth essentially is to optimize all these things. Traffic light use, traffic patterns, energy use, emission reduction, and so on and so forth. So this gives you a general sense of what we mean by mitigation and adaptation. And we already saw briefly how the zero carbon energy sources or low carbon energy sources have to scale up to keep the emission scenarios bound to these various pathways. But we will see that in fact we'll have to begin to draw down carbon into the future to meet some of these goals. So we started looking at adaptation and mitigation, and we will look at more specifics of the sectors and the costs and how the costs will change with time if adaptation and mitigation are not implemented at the right time. And the right time is always subjective criterion. So this is just another cartoon which shows the cost of impacts versus cost of mitigation versus cost of adaptation. So if you take no action, obviously there will be less cost. The cost will be lower, but the cost of impacts will be much higher. So mitigation cost will be less. But as cost of adaptation goes up, you also end up in different places where the cost of impacts becomes less and cost of mitigation may go up, but depends on what combination of things are involved. For example, we said when we looked at this figure that there are many things that are overlapping between adaptation and mitigation. So this is involves not just socio-economic decisions, but also engineering decisions, political decisions, and so on. So it's not ever exhaustive in terms of the choices you have. It's just a cartoon. So let's look at some more details. Again, these kind of tables are kind of heavy in technical details, and the uncertainties are not always conveyed completely, and these are not even exhaustive. So let's look at some of the climate related drivers of impacts, and like before, we will look at level of risk and potential for adaptation by looking at the risk level with the solid color bar, and then how we can go back with the potential for adaptation. So how much of the risk can be reduced if we put resources into adaptation. So the drivers, obviously the warming, extreme temperatures, so warm nights, warm days, reduced cold nights, cold days, the drying trend, which is obvious in many places, extreme precipitation. 2018 has been an exceptionally wet year in many places, damaging cyclones, flooding, storm surge, ocean acidification, and carbon dioxide fertilization, which is essentially the ability of the plants, some of the vegetation, to grow faster because there is elevated levels of carbon dioxide in the air. We discussed that a little bit before. So what are the key risks? So these are what are called global risks. So there are things like reduction in terrestrial carbon sink with warming. The soil moisture is reduced and the soil actually begins to respire carbon dioxide faster in a warmer temperature. This data already exists and it can also be reproduced in a lab with experiments warming the soil and so on. And the carbon stored in terrestrial ecosystem is definitely vulnerable to loss back into the atmosphere, and it's also related to increased fire frequencies, which is very clear in some of the regions in the world already, but even in a place like India there are lots of wildfires and there is a competition with water and so on that has to be also considered. So here the confidence in these is minimum. So, at present the risk is low. In the near term it obviously increases, and you can see that there is already potential for adaptation. In the long run obviously risks increase, and the risk reduction due to adaptation does not increase with time, because the adaptation options that include things like managing land, reducing deforestation and forest destruction, reducing fire and other disturbances, and non-climatic stressors, which essentially means converting forests to agriculture or agriculture to urbanization and so on. So, there is a limit on how much of this you can do, especially considering the continued population increase and so on. So, the main drivers here are the warming and the extreme temperatures. There are boreal tipping points that we talked about, and we already said before that there are very few adaptation options in these high latitudes. So, this is bad news, and again the drivers are extreme temperatures and the background warming. The Amazon tipping point we mentioned when we look at global map. You can make policies and market measures to reduce deforestation and fire. The details are not there, but essentially policy is to reduce logging, for example, and the market measures are to also reduce the demand side of the logging business. How do you do that? There are already many recycled wood, compressed wood, artificial wood, and so on and so forth, that are in fact better at water resistance than natural wood in many cases. And the adaptation options here are substantial. So, this will take political and socio-economic strength to implement. Increased risk of species extinction, we looked at briefly what those are. So, I will not go into the details, that you can look at, and here the confidence is fairly high. The adaptation options include reduction of habitat modification and fragmentation. So, the thing I want to emphasize again is that even if you have a piece of forest and you fragment it, you might think you have saved the forest by saving pieces, but actually that fragmentation disrupts many functioning of the ecosystems, which has significant impact on species extinction. Pollution or exploitation, invasive species, the migration, shipping business and so on have huge abilities to move insects, plants, seeds and so on to different regions. When you say invasive, essentially a species that is able to compete better than the species that have already existed in a region. So, it is not a really very scientifically robust term to call someone invasive, because we can be considered very invasive because we have taken over the whole planet and we are competing with everybody, and we are doing much better in terms of destroying all other species. Are we invasive? Maybe. So, protected areas can be expanded, dispersal can be assisted, which means we can artificially begin to move certain species that are unable to keep up with the climate velocity or the warming rates and so on. And ex situ conservation, in other words, you create places, for example, in Svalbard in Norway, all the grains are being stored in a frozen facility so that we do not lose the biodiversity. So, there are many ways in which to do ex situ conservation. Obviously, it may be much easier on land than in the ocean, because in the ocean, for example, the fish move long distances. Species like tuna and whales and dolphins can move thousands of kilometers depending on season, breeding and so on. So, creating marine protected areas, for example, has had some success, but maybe there will be moving marine protected areas in the future and so on. So, the climate drivers here on land are the drying in addition to temperatures and extremes, and again the risk increases in the long term with warming, but the adaptation options are not increasing in proportion. Global redistribution and decrease of low latitude fisheries paralleled by a global trend of catch, which is having smaller fishes. So, as we exhaust bigger fishes, we begin to come down into smaller and smaller species, or also there is a new way of catching a small fish a new purpose, because when you have things like aquaculture or farming fish, they are fed various things, and oftentimes they are fed small fishes which they used to catch themselves, let's say. We are doing that now. So, this is called fishing down the food web and so on, but let's not get into the technical details, but I think you understand what this is. And this is largely related to the marine heat waves and ocean warming in general, expanding tropics and so on. So, increasing coastal poverty at low latitudes as fisheries become smaller. So, the adaptation issues and prospects include partially compensating with aquaculture, marine spatial planning, and enhanced industrialized fishing efforts. So, lots of countries do the so called industrialized fishing, where boats are going far away, like in the Western Pacific, for example, lots of small islands, that Kiribati, Fiji, Vanuatu, and so on. They sell their fishing rights to countries. So, Japan, US, Spain, China, France, etc., are coming from very far away with big ships, and they are trawling the bottom. They are using various methods to catch fish. So, how do you protect these? So, the risk is already getting to be significant, and in the near term you can see that it is expected to remain somewhat similar even into 2 degree centigrade warming. It does go up with 4 degree centigrade warming, but this uncertainty here is low, because how the geopolitics plays into the reliance of some countries, some coastal countries that are not rich on fish for protein, depends on various factors that we are not very good at accounting for right now. Reduced growth and survival of commercially valuable small fish and other calcifiers like reef building corals and calcareous red algae, and the impact on them due to ocean acidification. Obviously, that is more to do with carbon in the water and ocean acidification. So, the adaptation issues are that evidence for differential resistance and evolutionary adaptation in some species exist. As I said early on, some corals, for example, in the Red Sea may be responding very differently to warming than the Great Barrier Reef or the Caribbean seas. So, we need to understand which species have better adaptation capability, and as CO2 increases, they are also likely to be limited. The adaptation options include exploiting more resilient species and protecting habitats with low natural CO2 levels. Of course, reducing pollution and limiting pressures from tourism and fishing. So, there are many agencies which look at fisheries in international waters. So, just briefly, fisheries is very different than agriculture. In agriculture, you put in the seeds, you put in fertilizers, you irrigate, and you expect certain outcome. Whereas fisheries, it is running by itself. So, we do things like maximum potential yield and so on, that are based on output on which we have no real control other than having maybe a negative impact through acidification, fishing pressure, and so on. So, these international agencies try to protect the species like swordfish or dolphins. So, you will see tuna cans that say they are dolphin free or dolphin safe tuna and so on. So, international bodies try very hard to enforce rules even in international waters where nobody has authority. So, how do we manage these so called shared resources, or what are called commons? We will come back to that later. So, the global commons and so on and so forth, that is always challenging. So, you can see that the risk is fairly high, supposed to remain similar, but here the confidence is also high. With warming, the adaptation options begin to almost, well, they do completely disappear unless we have a very new way of developing ecosystem models that are capable of doing predictions of fisheries so that they can be managed properly. And I will come back to that at the end of this discussion. Marine biodiversity loss with high rate of climate change. As I said, it is not just how much it warms that is important, but how fast it warms. That determines how many species can really adjust. So, adaptation options are limited to reducing other stresses like pollution or limiting pressures from coastal activities such as tourism and fishing. One thing that is not discussed here is the disease pressure. As waters warm, more microbes survive, more viruses, bacteria and other pathogens that are harmful to some fish and also to human beings. And that is true also on land and water on land. Why people who come from high latitudes get sick in the tropics is because there are more bacteria and microbes in the water. People who live in the tropics may be more immune to it than people who come from outside. So, this is also true with global warming, that the warmer waters begin to have more microbes, and we basically know nothing about the disease pressure, which is a huge problem that is not addressed even in the IPCC assessments. So, the risk is fairly high already, and there are some options now, but as soon as we go into the future decades, you can see that the risk increases, but the adaptation options almost disappear. The others, negative impacts on crop yields and increases, projected impacts the across various crops and regions and adaptation scenarios into 2030 and 49 show some yield gains, maybe more than 10%, but as we go into the future, the negative impact on yields begin to increase. We already saw this a little bit. So, in the beginning, in the near term, there are some indications that things like carbon fertilization and warmer temperatures that are still below the optimum or damaging temperatures for photosynthesis will increase the yield. So, right now the risk is low, adaptation options are available, but when you reach certain warm temperatures, you go beyond the optimum temperatures for photosynthesis. So, photosynthesis does increase as temperature increases, but there is an optimum efficiency beyond which any warmer temperatures begin to make the crops wilt in heat, the crop yield begins to drop. So, then the adaptation options almost disappear. And here the risk factors include not just extreme temperatures and temperatures, but also extreme heat, acidification of soil moisture and extreme rainfall. Urban risks in water supply systems, already many issues becoming obvious. So, this depends on adaptation strategies for network infrastructure, demand side management. So, getting people to learn to use water carefully and sustainably, ensure sufficient water supplies and quality. Again, as temperatures increase, water quality has to be monitored very carefully because pathogens also increase. So, flood risk reduction also has to happen because every time there is a flood, the water quality gets severely affected and disease incidences go up. The incidences of cholera, for example, always go up when there are floods, especially in rural areas where people may be not having piped in water supply. The other thing that is not mentioned here is that leakage of water systems in urban areas causes extensive loss of water. So, just stopping dripping faucets and leaks in the pipelines is extremely important. So, floods, heat waves, extreme rainfall, risks with some adaptation, but in the long term adaptation options begin to be almost non-existent. These are all kind of based on what technology and science we have now. So, there is always a hope that as we go into the future decades, so much attention is being paid to climate risks that the market forces or curiosity driven basic research and innovation, all the investments in education, climate education and green technology and so on will create newer adaptation options. So, the options that are being imagined are limited also to some extent by what knowledge we have, what technology we have at this point. Okay? Just keep that in mind. Energy systems in urban areas already big concern. So, urban centers are obviously very energy intensive. If you drive around in a city at night, it's almost like daylight because all the shops leave the light on. And enormous, there are very nice satellite images you can Google and find, nighttime pictures from satellites. Tremendous amount of lights in, especially in city centers. Okay, so energy related climate policies on mitigation are needed. Few cities have adaptation initiatives underway now. So there is lots of coordinated efforts like Resilient Cities by Rockefeller Foundation and so on, where cities are beginning to identify their vulnerabilities to climate, urban floods, energy infrastructure, water supply and so on, and they are beginning to create solutions, including things like smart city, which has started in India, where things can be coordinated. There are other buzzwords like Internet of Things, where you connect all the electronic and digital instruments with internet, so that if one fails, the other one knows and then takes proper action, etc., etc. So those are some innovations that are coming along. Okay. So again, heat and floods are a big risk. You can see that the risk is already very high. Many cities are already experiencing energy system risks. In the near term, it remains somewhat similar, but the adaptation options are increasing, because right now the policies are not in place yet, despite all the coordinated efforts. And the long term risk is expected to actually decrease because of renewable energies, local grids or microgrids, maybe individual home based energy systems like rooftop solar, neighborhood wind energies and so on and so forth. So adaptation options in this case actually may increase into the future. Associated housing risks in the urban areas, with high confidence we can say that the storms, floods, extreme rain events and heat are going to create risks that will also increase, but fortunately we may also have adaptation options to reduce the risks, and that is where the adaptation in terms of codes for buildings, storm-proof constructions, storm-proof windows in high latitudes where winter energy consumption tends to be very high. This could be true for North India, for example, or insulated windows so that the air conditioning is not being lost to the outside with heat and so on. So all those are important. So right now the issues are poor quality, inappropriately located housing is often most vulnerable to extreme events. So when you look at many of the flood events in India, there is obviously high rainfall, but the loss and damage can be much higher than expected because houses have been built inappropriately, constructions are poor standard and so on. So you can find many examples where this is the case. So the potential to adapt housing and promote mitigation and adaptation and development goals simultaneously remains. So the adaptation options are available. So high value infrastructure, housing assets and broad economic effect is possible from extreme events into the future. And cities are complicated because everybody moves to the city because there are opportunities for jobs, but cities are also known as innovation hubs. So in general, if you plot the so-called metropolitan statistical areas, the population is higher, but the number of patents tends to be higher, number of startups, innovations tend to be higher. So it's always a challenge to say how will you deal with urbanization. There are many ideas on also adaptation and mitigation, which include building housing and working spaces in what are called mixed neighborhoods, so that people don't drive too much, that you can almost bicycle to work or even walk to work, or there are buses and trains that are always running around so that you don't have to worry about having your own car even. And so on. So there are many adaptation options that will become available. Just to run through a few more examples, displacements associated with extreme events. So obviously some issues and some adaptation options. Displacement is going to become more likely. You can see that there is some ups and downs here. So you have to kind of go through to see what technical assumptions were made in the models to increase the near term risks, but somehow reduce it, and what adaptation options are there. So, do not think of this as reduced risk, think of this as a risk that exists, but adaptation options that can reduce the risk. That is exactly what it is trying to say. So, do not just compare the colored bars and see that here the total risk is higher and adaptation options are also fewer. Violent conflict, there are many examples already, as I think I mentioned already. The Syrian war, for example, can be traced to the beginning of the drought in 2008-2009, how it affected the wheat production around Damascus and how the unrest started, and then other multiplying factors got involved in terms of differences in religions, ethnicities, and so on. So, climate is always one of the so called multi-stressor factor which begins to add to ongoing problems. So, water is always a big issue that begins to increase violence and conflicts, and also it is known now that elevated temperatures, hot temperatures make people more violent. There is just research that shows that. So, there are many ideas like buffering rural incomes against climate shocks, early warning mechanisms. I will come back to this when we look at floods over India. Even when there are early warnings, implementing the early warnings into decisions is not an easy task. So, there are many issues there. There are well established strategies for managing violent conflicts. Do we believe that? Wow. Look around the world and decide for yourself. So, extreme heat and dry days, extreme rain, storms, etc. Already there are many places with risks, but adaptation strategies also exist. With time, the risk goes up, but the adaptation strategies also exist. I would recommend here books like Non-Zero and by Robert Wright, or Steven Pinker's books, which are more optimistic about how humanity will evolve in the next few decades, how it will become more cooperative, and how violence has actually decreased despite the appearance of constant violence and so on. So, these kind of socio-economic factors and human behavior are important, and I will come to that in a few minutes. Declining work productivity, this is somewhat hard, but it is already clear that heat waves and of course also floods and so on have a severe impact on productivity and the daily labor lost, years of life lost, and so on and so forth. See, adaptation options are now limited for people who are dependent on agriculture. You have to work outside. So, pre-monsoon season, March, April, May, when they have to prepare the field for the rainfall, it's very hot and it's getting hotter, and they have to work outside. They of course wake up at 4 and try to get work done before 10 and so on, but still you know that every year there are several hundred, sometimes several thousand deaths in India. So, that adaptation option is low for those people. Adaptation options are also limited in the construction sectors, and adaptation of limits may be exceeded once you reach 4 degree centigrade warming. So, the adaptation options are basically non-existence once you go beyond, which means the mitigation cost will keep going up. How do you protect farmers? How do you protect construction workers and so on? Reduced access to water for rural and urban people. So, there are several adaptation options. Risks are right now on the low end, and adaptation options are available. So, you can look at the pie chart of the water use and see where the domestic use, industrial use, and so on exist. In almost all over the world, agriculture is the largest user of water, obviously, irrigation, etc. So, adaptation options include drip irrigation and so on, but also bigger plans on crops themselves, genetically modified crops and so on, which have all kinds of other controversies. Okay. So, that is kind of a quick run through several areas where adaptation is possible and risks exist that will grow with warming. Now, the mitigation costs and consumption of growth in baseline scenarios. As I said, baseline scenarios basically means we let the emissions continue, we don't do much to reduce the emissions. So, here is the consumption in corresponding baseline scenarios expressed as percentage increase from 2010. So, the corresponding baseline scenarios, obviously the consumption goes up. Corresponding to that, with time the consumption percentage also goes up, and this is the percentage point reduction in annualized consumption growth over the 21st century in percentage points. So, this is kind of complicated calculation where you define annualized consumption and then it has a metric, and then you look at the reduction, and you can see that the uncertainty ranges can be high. So, if a point reduction of 0.03 has uncertainty from 0.01 to 0.05, 0.04 has 0.01 to 0.09. So, as the reduction goes up in points annualized consumption growth rate, the uncertainty also goes up. Nonetheless, the reduction required relative to the baseline also goes up in each case. So, here is the range of carbon dioxide increase that we want to aim for. So, if we want to remain in this range, this is the kind of reduction we need. How do we do that? We will see in a minute that there are some ideas on how to do that, but again the big uncertainties come from the fact that we don't always know what new things will come that will make it more efficient anyway. So, the cell phone batteries, for example, which may be more efficient, energy production may be less carbon emitting, water supply may be done in a way that reduces consumption automatically. So, it basically comes down to food, energy, water. If we keep tracking those things and remembering that at the gross level we are looking at energy intensity of GDP and carbon intensity of energy, this is now consumption from individual level that adds up to that demand. So, GDP increase usually comes with more energy use, but is there a way to reduce that energy intensity and so on. So, higher the emission you allow, less reduction in consumption is required, but as you reduce the carbon dioxide we want to allow in the atmosphere as we go into the future, remember that this is the range that is going to keep the warming below 2 degrees centigrade. That is something you should always kind of try to remember. RCP 2.6 wants to keep the warming to less than 2 degrees centigrade, but you can see that the range of reduction in annualized consumption with reference to the baseline from 2010 is pretty huge going into 2100. So, already we should be starting and quickly ramping up by 2050 and then be able to reduce consumption by a lot into 2100. Another complicated looking table, but let us just look at it carefully. Increase in global mitigation costs due to either limited availability of specific technologies or delays in additional mitigation. So, if you start the mitigation process earlier, then it becomes easier and easier to keep the goals of carbon emission into the future. Okay? And if you delay the mitigation efforts relative to the cost effective scenario, the relative cost is going to go up. So, here various color schemes are used. They are basically where various models have run different scenarios, and if all models are successful, it is shown in certain color, green color with number of models written in large numbers, and when less number of models are successful in creating the solution needed given the mitigation options. Do you really need to know all these sorts of details? At least you should know that mitigation options are there. There are multiple options. Many scenarios are run with many models, and each model has a slightly different way of doing things, which is not a bad thing. It is like having many cars. You buy a different car based on what somebody told you or whether you liked the shape, the size, number of passengers and so on. The same with climate models and integrated assessment models. They are developed over time by different groups, like a US group might be focusing more on high latitude weather and climate and not paying so much attention to the tropics. Whereas, when India started developing its climate models that we will talk about, it wanted to focus heavily on the monsoons and not so much on high latitudes. Can they be done differently? Yes, because the processes are very different. You can focus on one region. For example, a four-wheel drive is better suited for mountain climbing, whereas in a city you have a front wheel drive or a rear wheel drive. If you have snow, you have to worry about front wheel drive versus rear wheel drive, and so on and so forth. Okay? Same philosophy applies here. So, just quickly, this is the increasing range of CO2 that different scenarios assume, and this is the percentage increase in total discounted mitigation costs. Okay. This term discounted, I do not know if many of you heard of it. Very quickly, it is an economic term. Basically, that means the value of the money goes down into the future and the value of the investment you make now goes down in the future, whether you build a bridge or you take a loan and so on and so forth. That means, when you estimate future costs in terms of current dollars, you assume a certain rate of discount, in other words, how the value decreases into the future. Just quickly. So, if no carbon capture and sequestration, if there is a technology that can take carbon dioxide somehow out of the air or out of the car emission or the power plant emission and sequester it, which means hide it away from the ocean and the atmosphere and the land somehow, then the cost is going to be 138% if you delay the mitigation. So, this is 2015 to 2100 relative to the default technology assumptions. Again, all kinds of buzzwords, but the main thing to note is that if you want lower emissions, the cost is going to be relatively high. If you allow for higher emissions, the cost is going to be relatively low. But without worrying about that, just look at the kind of things that are considered. Nuclear phase out. Nuclear power is considered beneficial to climate change because it emits much less compared to coal or hydroelectric, but obviously there are many safety issues, mining issues, and so on and so forth. Limited solar and wind. So, if you do not implement enough solar and wind, then you are going to have mitigation cost increase with respect to availability of technologies. Limited bioenergy, and these are mitigation cost increases to delayed additional mitigation until 2030. So, medium term costs and long term costs, you can see that if you allow for higher emissions, you are going to have lower increases in costs, but if you want reasonable emissions and reasonable warming limits, then obviously the costs are going to be higher. So, this should just give you a sense. Only remember that there are various mitigation options that are on the table, but obviously you have to decide when they will be deployed, how much they will cost, and what happens if you keep delaying them. For example, India has committed to Paris Treaty and it wants to reduce its carbon emission, let us say, by 25% by 2030. How is it going to do that? Obviously, it will want to implement solar and wind, and it wants to also reduce its coal burning and also do more forestation. It is called the afforestation as opposed to deforestation. So, somehow it has to keep track of its carbon emissions, and it has to keep track of how the costs will increase if it keeps delaying implementing the plans. That is always the key. But the good news is that there are co-benefits of climate change mitigation for air quality. I will show a little bit later that air quality is a huge issue already. I think you know that because we looked at some images and data already, but there are numbers on the premature deaths due to air pollution over India, China and all over the world that are remarkably high, stunningly high. Okay? So, if you apply mitigation, the change with respect to 2005 in black carbon, in the baseline where you do not do much, it could be reduced because of solar and wind increasing, but it could increase if we continue our consumption, especially fossil fuel burning for vehicles, heating, cooling and other things. But as you begin to implement stringent climate policies, you can see that the black carbon drops below the 2005 level significantly, maybe by 50%. Increased pollution here and decreased pollution here. So, the baseline sulfur dioxide is going down basically because coal consumption on average is going down, but with stringent climate policy you can reduce it almost completely up to 75%. One can hardly overestimate the value of improved air quality. If you have kids playing outside, you know that they are all having many asthmatic problems, breathing problems, even older people and so on. So, these are so called co-benefits. So, even if we do not realize our goals of climate change, improving air quality and water quality is going to be a phenomenal co-benefit from climate change mitigation policies, and the cost has to be estimated, and there are many available estimates of how much of the GDP it is going to cost if we do not do anything, and that cost keeps going up with time into the long term with different rates of warming. Okay? So, we will come back and continue this discussion and try to see what are the policy tools that are imagined by the IPCC for implementing these adaptation and mitigation, because there is always two issues. One is the CO2 at global level, we are talking about 450 to 800 or whatever. Obviously, one country cannot do it, everybody has to participate, but everybody has to do adaptation and mitigation at a local level. So, who pays for it? How do we make sure that everybody follows the rules? So, there are global governance issues and there are local governance issues, global economic issues, local economic issues. We will discuss those when we come back. See you next time.